Hello everyone, my name is Shi Jie, comes from Dongsil University Graduate School Visual Content Department. Today I want to report is research on efficient bone binding method suitable of advanced skeleton. Part 1 is abstract, Part 2 is introduction, Part 3 is related research, Part 4 is efficient bone binding method based on advanced skeleton. Part 5 is comparison of experimental results. Part 6 is conclusion. The last part is references. Part 1 Abstract. With the rapid development of bone binding technology in 3D animation, the plugin is widely used in visual content and game production, especially in the field of animation production. However, when it comes to connecting the bone data in advanced skeleton with Unreal Engine, the traditional engine binding process cannot use the one-click scanning function. This research explores an innovative bone binding method that replaces the traditional binding process with name matcher technology and successfully gradient and engine elimination. The experiment used a human model to compare the animation effects of the original engine binding and the name matcher binding. Research results show that using name matcher significantly improving the efficiency and the convenience of bone binding. This research provides innovation ideas for bone binding, which can significantly simplify the operation process and improve overall work efficiency. The keyword is 3D animation, bone binding, advanced skeleton, Unreal Engine, and name matcher. Part 2 Introduction. The rapid development of 3D animation has brought unprecedented opportunities for visual content creation and game development. In this field, bone binding has become the key link in giving characters vitally. Among them, the advanced skeleton plugins applied an important position in bone binding with its powerful, fast scanning and weight brushing functions. However, when connecting the bone data in advanced skeleton to Unreal Engine, this feature cannot be used, and the bone placement and the weight distribution can only be done manually, which becomes an urgent challenge that needs to be solved. The traditional engine binding process seems somewhat helpless when faced with the one-click scanning problem. The existence of this problem restricts animator from taking full advantage of advanced skeleton in Unreal Engine. In order to seek a more efficient solution, this study introduced name matcher technology in an attempt to improve the overall production efficiency by replacing the traditional engine binding process. In order to comprehensively explore the advantages of the new method, this study used a human model as the experimental object, conducted binding experiments separately, and compared the animation effects of the two binding. Through the analysis of the experimental results, we will be able to gain an in-depth understanding of the actual application effects of name matcher technology in bone binding, whether it can efficiently correct the movement and the limitation of the engine binding process. The main purpose of this research is to explore an efficient bone binding method, provide the production team with convenient and fast binding ideas through practice, and promote the continuous innovation of three-dimensional animation technology. Part 3 Related Research 3.1 3D animation. 3D animation refers to animation created and presented using computer technology in which objects, scenes, and characters exist in the form of virtual models in 3D animation space. The production process of 3D animation involves the use of professional 3D modeling software to achieve the movement, deformation, and the interaction of objects by exploitation in virtual 3D model and setting animation keyframes on the timeline. 3.2 Bone binding. In 3D models, bones are usually represented as a hierarchical skeleton that contains joints and bones. Bone rigging is the process of association these bones with the vertex or control point of the model. Common bone binding technicals including skinning and weight painting. Skinning refers to connecting bone to the surface of the model, while weight binding assigns one or more bones to each vertex and controls the degrees of influence of each bone on the vertex through and the weight value. Together, these technologies forms the basis of bone binding, enabling more freedom to create vivid and natural 3D animation effects, but problem due to the higher complexity of the workflow still exists. Microprocessor proposed a new animator rigging method for character animation, experiencing relative skin deformation by generating muscle systems from predefined structure to adapt to the skin surface sculpted by the artist, thereby conveying relaxed muscle movement effect. This approach can be applied to interactive application and has thereby been integrated into chromatic character animation systems. Animation refers to animation created and represented using computer technology in which objects, scenes, and characters exist in the form of visual models in 3D space. Animation space. The production process of 3D animation involves the using of professional 3D model software to achieve the movement, deformation, and the interaction of object by explanation and visual 3D model and setting animation keyframe on the timeline. 3.4 Name matcher. The name matcher function is to automatically match and third-party schedule data and use unif is skeletal data into the advanced skeleton system for fast character binding plugin, as shown in Figure 1. Part 4. The efficient bone binding method based on advanced skeleton. This section details the method of efficient bone binding. Figure 2 is an ideal map. The experiment x-ray the flexibility of name matcher by comparing the final effect of two methods. The main purpose of research is to use name matcher technology to enable the one-click scanning function of advanced skeleton to be used normally when the import engine option is turned on. Not only does this allow you to place bones with one click, but it also avoids spending a lot of time drawing weight. 4.1 Traditional binding method in advanced skeleton. This section uses the human body model and bind the bone in the normal order. After placing the position of the bone to generate the controller, I found that the original one-click scanning data mesh function could not be used normally. A large amount of work can only be done by remodeling the model through traditional steps, as shown in the Figure 3. 4.2 Name matcher binding method in advanced skeleton. In this section, on the basis that the one-click scanning function cannot be used, the model is first imported into Mixamo for automatic bone application and simple skin drawing, and then the original file is selected in the exported FBX file. Import is into Maya again for name matcher production. Due to a version problem, there will be no ice bone, so two ice bones need to be set manually. After the bone setting are completed, Scanning is generated with one click. In this way, a set of human body models with complete scanning is obtained. The key to the experiment is use the Mixamo's quick binding as a bridge and use it as a base point in NameMatcher to bind the bond. This step only takes half the production time of the traditional binding process. The 5-part comparison of experimental results. This section finds through the final results of two binding methods that the advantage of name matches binding method is that it automatically confers bond position and has better automatic scaling effect as shown in figure 4. Part 6. Conclusion. By studying the bond binding process of the advanced skeleton plugin in Unreal Engine, this study proposed an efficient bond binding method that replaces the traditional binding process with name-matcher technology. Experimental results showed that using name-matcher significantly improving the efficiency and the convenience of bond binding and successfully current the limitation of the engine binding process. This innovative method not only makes full use of the advantages of the advanced skeleton plugin, but also avoids the problem of being unable to use one-click scanning when importing Unreal Engine, greatly shortening the operation process and improving overall work efficiency. This research provides an innovation bond binding idea of the field of 3D animation production and provides a useful reference for improving production efficiency and optimized workflow. Future work can further explore the application of name-matcher technology in other 3D animation production tools and further optimize the method to make it more universally applicable to different scenes and projects. At the same time, you can also comparing it with other advanced bond binding technologies to conduct in-depth research on its performance and applicability in different situations. This will help promote continuous innovation and progress in 3D animation production technology. The last part is references. This is my references. Thanks for